see, let's put the general form first. Hopefully this means something to you. So that would be an x minus c1, x minus c2, x minus c to the n, whatever that n may be. In this case, it's 3, so there'd just be this, right? So we're trying to figure out what goes in what place here. And then what we're going to do is eventually, after plugging in the c's, we're going to go back and we're going to solve for an, what that coefficient in front of this is necessary to make this true. And hopefully it'll make sense by the time I'm done. Okay, so there's a reason there's 3 sets of parentheses, right? C1, C2, and then I put Cn, but technically in this case it's just going to be a C3, third one. Okay, so here we go. So I'm going to replace that with, we'll keep the an, x minus. First thing they mention is a 4. So I'm actually going to plug in a 4 there. Then after that, I'm going to have a 5i. Now, whenever you have i's, I know it only listed once, and you say, oh, there should be 3. Why is it listing only 2? Because i's are always going to go in a pair of a positive and a negative. Positive and a negative. Okay. Now, I'm going to have to simplify this before I can solve for this part right here where I'm going to plug in the negative 1. I can't really plug in the negative 1 yet because I have an imaginary number. So I am going to have to simplify this. So this is the difference of squares, right? We have the conjugates. I'm going to multiply these conjugates together. That's going to give me x squared minus 25, sorry. 5 times 5 is 25, and that's going to give you I squared. Now, because you have an I squared there, that's going to be replaced with a negative 1, right? Which means I'm going to flip the sign of this. You can just skip straight down here to where it flips the sign to a plus 25. So whenever you end up with a situation where you know you're going to end up with this I squared situation, you can simply flip the coefficients, flip the sign, right? So this used to be negative 25, straight to 25, right? So I can just skip that step. You don't actually have to write the negative 1 there and then multiply negative 25 by negative 1. All right, so we end up with x minus 4. Okay, so far so good. Okay, so now we actually know what f of x is. What is the function? But what we don't know is we're missing this part right there. We actually don't know what that coefficient right there is. Okay, so they gave us some more information. What they gave us is, well, if we plug a negative 1 in here, if we plug a negative 1 in here, that we know we are going to get a 130, right? It says right there. If I plug a negative 1 in there, I get a 130. Okay. So let's see what that means. So if I say a negative 1 minus 4, I would say that's negative 5. If I say negative 1 squared, that's a positive 1. Positive 1 plus 25 is a 26. So we would say a n negative 5, that's a 26 is equal to 130. I'm trying not to skip steps, but there's a lot of rewriting if I don't skip steps, so might have to skip steps in the future. So negative 5 times 26 is negative 130. And we're basically saying that if I multiply an by negative 130, right, which gives me, I think I have just enough room to write this here, negative 130 an. I treat the an like it's a variable. Gives me 130, right? So if negative 130 an is equal to 130, that means an must be equal to negative 1. I simply just divide both sides by negative 130. Totally ran out of room here. My bad. All right, so you're saying a 130 divided by negative 130 is negative 1. So we end up with that an is equal to negative 1. Now what I can do is I can go back to the equation that I have right here, and I can rewrite the entire thing. So now my function is something like f of x is equal to negative, and then it would be x minus 4 times x squared plus 25. Okay, so use it to graph the function and verify the, if you are using graph, I'm not going to use that. If you are using graphing utility, use it to graph the function and verify the real zeros in the given function. So I'm not going to do that. But I did find the real coefficient satisfying the given condition. So we did that. So this is our new equation right there. And I apologize. I know my 4s look like 9s. It's an autocorrect thing. That did not make it look better. Okay, so I did the first one. We're going to do the second one the same basic way. So except now we're going to have 4 parentheses. So the general format for this would be, oops, that's supposed to be an F, believe it or not. F. So we're going to say F of X is equal to, so the general format would be the same as the previous one, but instead of having just 3, we are actually going to have 4, right? Because we have 4. So we have 4 of these things we're trying to figure out. Now they list an I and they list a 3I. And just like I said before, whenever they have those I's, we know what that really means is we are going to have opposite signs. So we're going to say X minus I and X plus I. And we are going to have X minus 3I and X plus 3I. Opposites, right? Conjugates. Okay, so now we're going to have f of x. I need to simplify this a little bit, keep the a in. And when I multiply those together, I get x squared minus I squared. And now I'm going to flip it, right? Because I say negative I squared is the same as positive 1, right? Negative 1 times negative is a positive 1. Okay, so let's try the next one. So we're going to have x squared minus 9I squared. Except when I see the I squared, I'm going to flip that negative 9 into a positive 9. Okay, so now we have f of x is equal to this. Now, we're not done though, right? Because we don't know what that an is. So we actually don't know what our function is. Luckily, they gave us this information right here. They say, well, if we plug a negative 2 in, we get a 130. If we plug a negative 2 in, we get a 130. So, oops. So if I plug a negative 2 in here, square it, plus 1, and a negative 2, square it, plus 9, we know that all that must equal 130. Okay, cool. So we would say negative 2 squared is 4. 4 plus 1 is 5. And we would say negative 2 is 4. 4 plus 9 is 13. Right? Try not to skip steps here, but obviously, again, I'm running out of room again. And that's all still equal to 130. Okay, so at this point, we say 5 times 13 is 65. So we end up with 65 AN is equal to 130. I divide both sides by 65. And what that gives me is, well, AN must be equal to 2, right? Okay, so what I can do is I can go back over to where I had it written here. Therefore, we know that whole thing, that f of x must be equal to 2 times x squared plus 1, x squared plus 9, right? So let's do the coefficient. That's the thing. They're if you are good, find an nth degree polynomial. Okay, so we found our nth degree polynomial. This is a 4th degree polynomial, right? 2 exponent right here plus 2 exponent right here. So that's a 4th degree polynomial. And it goes along with all these different conditions right here of the I and the 3I. And if x is equal to negative 2, it's equal to 130. We did that. Awesome.